All right, so section 4.8 is Newton's method. Newton's method is used to find zeros, which is just, we should know, x-intercepts of a function using the equation of a tangent line. Okay, so where else have we used the equation of a tangent line? Hopefully remember linearization. If we want to approximate a y value of a function, we use the equation of the tangent line. Okay, here's the idea of Newton's method graphically. So I have a function. Okay, here's its graph. There's my function. I want to find this x-intercept. And I can't do it, or I'm not going to do it by setting the equation equal to 0. How can I use the equation of a tangent line? Pick an x value, somewhat close to the x-intercept. There's x1. Draw the equation of the tangent line. Okay? Where that tangent line crosses the x-axis, which we can find, is your new x value. We'll call it x2. Now, draw another tangent line at x2. There it is. Where that tangent line crosses the axis is x3. So now draw a tangent line at x3. What's happening? Where the tangent line crosses is getting closer and closer to the actual x-intercept. There's the idea. So you are going to use the equation of tangent, where the equation of the tangent line crosses the x-axis, it's going to get closer and closer to the actual 0 of the function. Okay? That's the idea of this. You're going to have a formula that you're just going to use. It's not that hard, but that's the idea. So we know, here's my equation of my tangent line. Normal. We've done it a million times this year. Y minus the y value equals the slope times x minus. So if you let the x-intercept be x2 comma 0, because what I just did, I said what? Find the x-intercept of that tangent line. So plug 0 in for y and plug x2 in for x. Okay, and solve for x2. I get x1 minus f of x1 over f prime x1. You're just going to repeat this over and over. Then you'd have an x3, then you'd have an x4. All this is doing is it's finding, what's x2, guys? x2 is that x-intercept. Okay, so in my example here, this was x1. Okay, when you drew the equation of the tangent line here, this is x2. So you found the x value there. Then you do it again. Okay, here's x3. So x2, x3, what? These are getting closer and closer to the actual 0. So you're just going to repeat this over and over. Here's Newton's actual formula. The next x value is equal to the previous one minus f of xn over f prime of xn. Okay, so let me show you and do a problem. Starting with x1 to be 2, find the third approximation. Find x3 to the root of the equation. This is saying, find the 0 of this equation that's near 2. Okay, so if x1 is 2, then you would start by finding x2. You're going to need the derivative. So the derivative of this is what? 3x squared minus 2. Okay, so x2 is going to be what? x1, which is 2, minus f of 2 over f prime of 2. The previous x value minus the y value of 2 over y f prime of 2. You do this out, you get, say, 2.1, I don't have all the decimals, I'm sorry. You are going to keep at least 4 decimals to this. I'm sorry, I don't have those written. Then I would do x3. Okay, so x3 would be now this answer, 2.1 minus f of 2.1 over f prime of 2.1. And I get 2.0946. Now you could keep doing this. And all you're doing is you're finding the 0 that's near 2. There it is. The 0 of this function is about 2.0946. Okay. I could, get it even closer by doing x4, x5, x6. Another application to Newton's method. Use Newton's method to find the 6th root of 2. You're saying, what the heck? Well, create a function. So what would f of x be? Okay, so you're trying to find the 6th root of 2 as some number x. So multiply both sides, raise both sides to the 6th. So I'd have 2 equals x to the 6th, and then subtract 2. So the actual function would be x to the 6th minus 2. Okay, the derivative would be 6x to the 5th. Here's the hard thing. You have to pick a starting point. So what do you want x1 to be? Well, about what is this number? That's what you have to think about. Okay, so x to the 6 equals 2. About what number is this close to? You can't pick like 5 because that's nowhere near. 5 to the 6 is not 2. 2 to the 6 is not 2. I'm going to start with 1. 1 to the 6 is 1, and I want it to be 2, so that's close. So I'm going to let x1 be 1. Okay, now I'm going to go through, I'm going to do this. So if x1 is 1, I'm going to go ahead and do the formula. So what would x2 be? x2 is 1 minus f of 1 over f prime of 1. Okay, so it's the previous value minus the function at 1 over the derivative at 1. Okay, and I should get 1.1666667. Now I do that again. x3 would be the previous number, 1.1666, we'll take 3 decimals, okay, minus f of that over f prime of that. And x3 should come out to be 1.12644. Okay, 368. Now, this correct to 8 decimal places is a pain. That means you stop when you get your answer and the next answer to be the same to 8 decimal places. Okay, so right now these are not the same to 8 decimal places. So I'd keep doing this. Okay, and it actually comes out to be the same all the way at x6. So if you do x4, I think you get the idea. You'd use this number. Okay, and x4 comes out to be 1.12249,707. Okay, so I'm getting closer, 1.12, 1.12. I need them all the same to 8 decimal places. That's when I can stop. Okay, and if I do x5, x6, I actually get there. And I just keep using this formula to do that. Okay, let me just set up the next one, and then I'll be done with this. So find correct to 6 decimal places the root of the equation cosine of x minus x. The first thing you always need is an actual function. So just subtract the x over. Okay, and then you have your derivative. For Newton's method, you need the function and the derivative. Okay, and now I need to know, where should I start? This is probably the hardest thing. What should you make x1? Well, what's the actual answer to this about? If you think cosine of x equals x. So, equals x. So cosine of x, we know, looks like that. Y equals x looks like that. There's the answer. About, what is that? I'm going to say it's close to 1. So I can start at 1 again. Okay, and then you're going to go through and do the formula. So x2 is going to be 1 minus f of 1 over f prime of 1. So you'd plug 1 into this. You'd plug 1 into this, divide them, subtract, and you get 0.75036387. And it says 6 decimal places, I kept 7. So now I do it again. x3 would be that answer, 0.75036,387, minus f of that answer over f prime of that answer. Okay. And you get for x3 0.73911,289. So I am only within one place now. I need to do this until the first 6 decimal places are the same. And actually you would go all the way to x5, between x4 and x5. The first 6 decimal places are the same, so I can stop at x5. Okay, so I hope you understand what you're doing. Okay, what you're doing is you're just finding the new x-intercept of each equation of tangent line and how you actually apply the formula. I didn't show every single step, but I think you're fine with this.